Jai Hind students. In our previous videos we have covered exercise 1.1. In this video we are going to study about exercise 1.2. But before that exercise we have to see some properties of integers. You can see on your screen, you can watch that it is written closure property, closure under addition. And you already know that when we add two whole numbers, any two whole number 2 and 3 if you take, and add two whole numbers, the result is again a whole number. Means addition of two whole numbers again gives another whole number, and obtaining again the same type of number here is closure property. Means add two whole number and the result is also a whole number. So the same property we are going to check about integers. And first add two integers and check your result. Is it an integer or not? We have two integers 17 and 23. You can see there we have two integers 17 and 23, and sum of 17 and 23 is 40. And you know, on number line these all are the integers. This is an integer. Add minus 20 and 0 and the result is minus 20. This is again an integer. Add these two integers 27 and plus minus 27. Again result is 0 and 0 is an integer. Add minus 10 and plus 3, result is minus 7. Again an integer. So eventually we can say that integers are closed under addition. Integers are closed under addition because you can see that result is again an integer. And let's check this property for subtraction too. Subtract 9 from 7. This time the result is, if you have to subtract something, there is a simple method. Just add additive inverse of this 9, and that is minus 9, and the result is again 7 minus 9. You know that how to do this. And this time subtract 7 from 9, that will be 2, but sign will be of minus here because here 9 is greater than 7. And 17 minus 21, so that will be what? Again add additive inverse of minus 21, that will be 21, and our result is 38. These both are integers. Add minus 8 and this minus 14, that will be this, and result is plus 6, again an integer. So we can write that yes, integers are closed under subtraction too. Are closed under subtraction. So the simple meaning of this property is when we add two integers, the result is again an integer, and when we subtract two integers, we have the result again an integer, again an integer. Here again we have another property which is called commutativity property for integers. And for whole numbers we are already familiar with this property, but let's revise that. This means actually when you add 1 and 2 whole numbers, result is 3. And when you just reverse this order, means add 2 then 1, again result is 3. Okay, here observe one thing. For addition, changing this order of numbers doesn't affect the result. and this property of whole numbers is called commutativity property, and we are going to check this property for integers now. We can see this is -8 and this is -9. First we add -9 in -8, and again we have just changed the order. You can see that it is -9 first, then -8, and then we add -8 in -9, and see the result. Add -8 and -9. This time we are adding two integers, but they have negative signs. This means that our result will have again a negative sign, that will be -17. And again here add these two integers. We have just changed the order, and again our answer is -17. See, results are same in both conditions. Again, if you add -23 and 32, our result is +9. And if we change this order, first write 32, then add -23, again result is 9. So here changing this order doesn't affect our result. So we can write addition is commutative for integers. Means if you add a then b, or add b then a, result is same in both conditions if a and b are integers. And if we check this property for subtraction, we have two different integers, 5 and -3. Do one thing. First subtract -3 from 5, that will be 5 minus -3, and here we have to add the additive inverse of -3, that will be +3, and our result is 8 here. What if we change the order? Means this time subtract 5 from -3, -3 minus 5, and our result is -8. You can see that after changing the order, results are different. So we can say subtraction is not commutative for integers. Subtraction is not commutative. Means if you subtract b from a and subtract a from b, these both are not equal and results are different. So this is the commutative property for integers, where addition is commutative but subtraction is not commutative. And we have another property which is associative property, and for integers we have to check this property here. Simple meaning of this property is, if we have three numbers a, b and c, and we want to add these numbers, what we can do, we can add these numbers first and then add c in that result. So you will group it like this, then add c, and if not this, you will add b and c first, then you will add in that result. So, or we can add b and c and then you will add this a in that result. So in case of whole numbers, these two operations give same result. What if we check this property for integers? So take three integers, any three integers, and for addition we will check this associativity property. If we have three integers, -2, 3 and -4, And we have to check this property for these three integers. Add these integers, -2 plus 3 plus -4, and again write it again here, -2 plus 3 plus -4. And first group these two numbers here, and here group first two numbers here. Here we have to complete this addition operation first in bracket. This is -2, second step, this is -2 and plus 3 minus 4 -2, and this is what, 3 minus 4, that result -1, and our result is -3. And we have -2 and plus 3, and result of -2 and 3 is +1. Okay, and plus -4, this means this is plus and this is -4, and we have the result -3. In both conditions you can see that we have the same result, so we can say that for integers addition is associative. For integers addition is associative. Addition is associative. Means you can add integers in any order as you want. Add a plus b, then add c, or add b plus c, then add a. The result will be same, but for addition only. Okay, keep this in your mind. For subtraction is not associative for integers. Only addition is associative here. And other operations, multiplication and division, we will check them later. Additive identity. Students, tell me one thing. What if we add 0 in any integer? If we have an integer -5, add 0 in -5, what is the result? Result will be again -5. If we add 0 in 3, what is the result? That is again 3. If we add anything 0, -10, again we have result -10. Here you can observe one thing, that addition of 0 in any integer doesn't affect the result. This means that 0 is here identity for the addition, so you can write 0 is called identity for addition of integers, or 0 is also known as additive identity for integers. And this is same for whole numbers and natural numbers. So do not forget this, 0 is additive identity. Now we will solve our exercise 1.2. In exercise, in our classwork, first question is question number 2. First question and question number 4 is your homework. Question number 2 is write a pair of negative integers whose difference gives 8. It is +8. So we have to write a pair of negative integers whose difference is +8. Here you can see variation in answers. You may have different answer, I have different answer. Because we have a number of pairs of these integers whose difference is 8. And one of them is, if we write here -6, we have to select negative integers. So first is -6 And what to subtract here? That our result is 8. If we subtract minus 14 from 6, check what is the result. We have to subtract minus 14 from 6, minus 6. You know what? To subtract, we have to change this sign and we have to put this value as a additive inverse of minus 14, and that is what? That is plus 14, and this time our result is 8. So the pair could be minus 6 and minus 14, which gives the result 8 as their difference. Write a negative integer. See the second part. Write a negative integer and positive integer whose sum is minus 5. Again we may have different answers, and if I write 4 and if I add minus 9 in 4, check the result is 4 plus minus 9, and that is what? 4 minus 9, and our result is minus 5. So here you can see a negative integer and a positive integer whose sum is minus 5. This is the positive integer and this is the negative integer, and sum of these two numbers is minus 5. So this could be the pair here. In C part, write a negative integer and a positive integer whose difference is minus 3. If negative integer is minus 1 and positive integer is plus 2, subtract this positive integer 2 from minus 1 and check the result. We have to subtract 2 from minus 1 and our result is minus 3. Yes, so you can see we subtracted these two integers and result is required, that is minus 3. So yes, this is the pair and that is our result. So do this in your rough copy and do not draw this line, that is here just to explain this thing to you. Question number 3. In a quiz, team A scored minus 40, 10, 0 and team B scored 10, 0 and minus 40 in 3 successive rounds, means back to back rounds. Okay, and which team scored more, and can we say that we can add integers in any order? So let's check first which team scored more. Total score of team A, that is add all scores, that is minus 40 plus 10 plus 0, minus 40 plus 10, and our result is minus 30. And total score for team B is, that is 10 plus 0 and plus minus 40, and that will be 10 plus minus 40, this is minus 40, 10 minus 40, and result is again minus 30. So you can write here both the teams scored minus 30, means score is equal. Team A and B scored minus 30. And second part of the question is, can we say that we can add integers in any order? Yes, you can see that we add these 3 integers first in this order, again add these 3 integers in another order, and both the times result is same. So yes, we can say that yes, we can add integers in any order. In any order. In exercise 1.2, question number 1 and 4 is your homework, and chapter and exercise 1.2 is completed now.